Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about graphs of polar equations. So the first example is r equals 3. So basically this means our radius equals 3, or it's a circle with radius 3. So we'll just go ahead and find the radius of 3, and then we can plot the points, and then we can just grab that circle. It's pretty straightforward and simple. To check this one, we can change this equation into Cartesian coordinate system equation or rectangular equation, and then we can verify that it's a circle center at the pole or the origin. So here we have r equals 3. We know that r is square root of x squared plus y squared equals 3. Then if we square on both sides, so this becomes x squared plus y squared equals 9. And we clearly know that this is a circle centered at origin and has a radius of 3. Let's look at another equation here, which is theta equals pi over 6. So this means the angle is pi over 6, and then radius is not given here. So pi over 6 is 30 degrees right here. So if we take theta equals pi over 6 and all possible radius, positive radius, then we are going to plot points right here. So these are the points right here, okay? And then if we take the negative radius, still the angle is pi over 6, so we'll plot the points on the opposite side or the other side of that ray. So it would be right here. So when we connect these points, this is just a graph of a straight line. So that is the graph of this equation theta equals pi over 6. Again, we can change this into rectangular equation and then verify that it's a straight line. So we have theta equals pi over 6. If we take tangent on both sides, so we have tangent theta equals tangent of pi over 6. Now, tangent theta is, we know that it is y over x, and then tangent pi over 6 is 1 over square root of 3. And then if we multiply by x on both sides, we get y equals 1 over square root of 3 times x. And we know that this has a form y equals mx, which is a line passing through the origin. Now let's look at another example here. So now when you have, those are the simple one, straight line and circle. Now when you have we are given equation like this, there are two ways actually we can graph this by hand. The first one is we can make a table. So you can just make a table. You can say, you can take theta and r. So you can take values of theta at 0, 30 degrees, 45, all those values in the unit circle. You find r, plugging them in here, and then you can graph it. So that might be a lengthy way of doing it. We already know how to graph a trigonometric function. So what we are going to do here is we are going to take this equation, and instead of saying r equals 4 sine theta, we'll take this as y equals 4 sine x. And we already know how to graph this one. So x is like theta, so this is the x-axis represents the theta, and the y-axis represents r. So if we graph the equation, and this is how it's going to look like, okay? Now, so here we'll translate this equation into our polar coordinate system. So what we do here is we see that the graph at 0, okay, the radius is 0. So the graph increases, so as the angle increases, the radius increases, and as the angle becomes pi over 2, the radius is 4. And then from pi over 2, the radius starts again to decrease, and as we hit pi, the radius is 0. And then again, the radius becomes negative from pi to 3 pi over 2. And then again, we have this radius starts to go to 0, and we'll have a radius of 0 here at 2 pi. So this is how we are going to translate this. Okay, so at 0, the radius is 0. Now the radius increases and it goes to pi, it goes to 4 at pi over 2, or at 90 degree the radius is going to become 4. So we'll just guess that it's going to look something like this. Okay, and then from pi over 2 to pi, the radius is going to decrease and it will get to 0. Okay, so from here the radius starts to decrease and eventually it will get to 0. Now from pi over 2, so this part, pi over, from pi to 3 pi over 2, we have this one. The radius increases, but it's a negative radius. So you might think like this. Okay, so from here the radius start to increase, and at 3 pi over 2, the radius becomes 4. You might think like this, but remember, when the radius is negative, we graph that on the opposite side. So instead of graphing here, we will be graphing here. Okay, so this point will go up here. So it's just going to overlap the first part of the graph. And same thing happens here, okay? So once we reach here, we might think it's going this way when we go from 3 pi over 2 to 2 pi. But actually, we have the negative radius. So instead of graphing here, we will be graphing on the other side, which is right here. So it's going to overlap to the second part of the graph. So we don't have this graph down here. It's just going to be that circle. So this is a circle. This equation represents that circle. Let's look at another example. Now here we have r equals 4 sine 3 theta. Again, we are going to do the same thing. This is theta and this is r. So we are going to graph that just like in the Cartesian coordinate system, and then we'll translate that here in the polar coordinate. So here at 0, the radius is 0. The radius becomes maximum, or 4 at pi over 6, and comes back to 0 at pi over 3. So let's go ahead and graph this part. Okay, so at 0 it is 0, becomes maximum, or 4 at pi over 6 means 30 degrees. So it's 4 here. And then at pi over 3, or at 60 degree, it comes back to 0. So it's going to look something like this. Now from pi over 3, the radius again it starts to increase and becomes maximum at pi over 2, but this is negative radius. So you always have to remember that one. Okay, below this axis means negative. So from pi over 3 to pi over 2, so it becomes, so from pi over 3, the 60 degree to 90 degree. Okay, so radius increases and becomes maximum, but it's negative radius. So we graph on the other side. Okay, so we are going to graph right here. Okay, and then again the radius decreases and comes to 0 at 2 pi over 3. So right here at 2 pi over 3, the graph is going to go back to 0. Okay, but here again we are going to graph on the other side. So 2 pi over 3 is 2 pi over 3 is right here at 20 degree, but instead of graphing this, so we are going to graph on the other side. So this is going to come this way right here. Okay, and so that's, we are right here now. So from 2 pi over 3 to pi, the okay, so from 2 pi over 3 to 5 pi over 6, the radius is going to increase. So from 2 pi over 3 to 5 pi over, so it's one at 150 degrees, going to go like that, and from there to pi is going to decrease and come to 0. Now again, from pi to 7 pi over 6, the graph is going to increase the radius, but it's negative again. So it is, you might be thinking over here, but instead of that, because the radius is negative, we are going to graph on the other side. So it's going to be this first leaf right here. And the process repeats. So we'll have another, we'll have another one down here, and then that process repeats. So for the sixth one, it would be right here. So we'll have it these rows with 3 leaf. Okay, So we can also use technology to graph this function. So I'm going to show you how you can graph this one in TI-84 calculator. Okay, and then I'll show you how to do this in Desmos also. So this last question, you can make a table and draw the graph by hand, but I'm going to show you this using TI calculator. Okay, so let me go ahead and pull up my calculator right here. So first thing you are going to do is you'll go to the mode and look over here. So it's in function mode. So we'll change it to polar. So scroll down and go to polar and enter. Now we can quit from here. Now we'll just go to y equals. So I have already put that equation here, 1 minus sine theta. Okay. So this is how it looks like when you change it to polar and hit y equals. See, we already have r equals, okay? I have already put it here. So if I go ahead and graph it, that's how it's going to look like, okay? So this type of graph is called cardioid. So you can graph any polar equations in the calculator. Now let me go ahead and show you this in Desmos. So in Desmos, it might look a little better. So we have r equals 1 minus sine theta. So this is the graph of that polar equation. Okay. So I'll just do this much for this video. Again, I'll see you again in the next video.